now.
Okay, so we're on?
Yep.
Great. So, yeah, welcome to BitShift. It's been a year since the last talk we had. We had some meetups planned, but of course, with the lockdown of society and the COVID and everything, yeah, it didn't happen. So we're very glad to finally be back. One of the most exciting things we had planned for 2020 was to have Scott Wlaschin visiting us in June after being at NDC. Unfortunately, that was not possible, but yeah, we're super happy that he's able to be here with us today. For me personally, Scott has been a great source of inspiration ever since I got hooked on functional programming and discovered F# for fun and profit. And the way he explained complex concepts in a way that I could easily understand it, that was something I really hadn't seen before. Most functional programming resources were all about monads, applicatives, functors, and such, and not so much about the practical usage of it. And things like how to structure your projects and how to solve problems in a functional way was something that at least I had great use of when starting working on functional programming. And also I've seen some of the talks that he's done, and I thought that since it's being also both entertaining and educational, it's a perfect candidate for a BitShift talk. So here we are. Scott will be talking for approximately an hour, and then we'll have a Q&A session after that. You can ask questions whenever you feel like it, and then we'll just go through them after the talk. Yeah, and actually, if there's if you can monitor the YouTube or the whatever you're using for questions, I mean, I can stop at certain points and answer questions then. Okay. Yeah. So maybe that'll be easier, because if it was live, it would be a lot easier to. So I'll try and stop every 10 or 15 minutes, and then okay, you can ask me questions about things. Yep. Okay, I'll leave the word to you then. Right. Okay. Let me share my screen. And I hope you can see all that. Yeah. Yes. Good. Okay. So this is designing with capabilities. And I'm going to explain exactly what I mean by this in this talk. So, okay. The code for this will be available on my website at /cap for capabilities. Right. Okay. So I originally did this talk for a domain-driven design conference. And it's an interesting thing that people focus on security. There are people who talk about security. There are people who talk about design, domain-driven design. There's people who talk API design. And I actually think there's a lot we can have in common between all three of them. And so that's what this sort of talk is about. What can we learn from security? What can we learn from domain-driven design that can help us write better APIs? So this isn't, when I talk about security, I'm not talking about things like OAuth and web tokens and stuff. I'm talking about security as a design principle. So we're going to borrow from security to improve our domain modeling and to improve our APIs. Right. So now, just before I get started, I just want to say I'm actually not a security expert. I mean, I know a lot about domain modeling, a lot about design, but I don't know very much about security. So I'm not this is not really how to make your programs super secure. This is more to do with improving your design. So I'm going to cover a number of topics. The first one is, what does security have to do with anything? What is these mysterious capability things? How does it affect API design? And then what happens when you start using capabilities? How does it affect the design of and the architecture of your overall system? And then one of the really cool things about capabilities is they're really good for business rules. Things like, you can only do this thing during working hours, or you can only do this thing once. Capability design is really fantastic for that. And finally, I'm going to talk about delegating authority, which is a really useful thing you can do with capabilities. Right. So let's start off with security and design. What does security have to do with design? So you've probably seen this kind of envelope, but this is what they call a security envelope. And in a security envelope, there's a little sort of transparent bit, and the rest of the envelope is opaque. And most people think that these envelopes are all about security. The idea is you can't see what's written on the letter, but you can see the address. That's the only thing you need to see. You don't need to see anything else. So that's one way of thinking about it. But let me give you a counter example. Let's say that I want to ask you to send this letter, but I actually don't care that you read the letter. There's nothing private in this letter. One of the nice things about a security envelope is it helps you focus on what's important. So if I asked you to deliver this letter, you wouldn't really know where to deliver it to. It's not very obvious what the address is. But if I mask out all the text except for the address, that helps you to focus on what the important thing is. So you could think of this, as security, but you could also think of this as good design, that a good design forces you to think about what's important, and anything which is not important is something you can't see. So it's not just about security. And which is really the whole theme of the first part of this talk is exactly this idea that hiding things that you don't care about is not a security thing, it's also a design thing. Hiding irrelevant information is actually good design. And this actually goes all the way back to 1971. So this is over 40 years ago, almost 50 years ago now. A famous paper by David Parnass, and he basically said, if you make information available, programmers will make use of it. If you expose anything in your API, people will end up using it, even if it's not in the best interests of the design. So the solution to this problem is don't make it available. Hide the information that you don't want people to see. And if they can't access it, they can't use it. So this is the whole concept of data hiding and encapsulation and modularity. All these things are very important design principles, and it's not a new principle at all. So if you think about software design, there's a spectrum, and on one end of the spectrum is you don't have enough information, so you can't really do anything, right? You don't know what you're supposed to do. You can't do anything at all. Now, sometimes though, you can have too much information, and if you have too much information, you can get unnecessary coupling. You have things where they depend on something that they really, really shouldn't depend on. You're not really supposed to know about this, but you end up using it anyway, and that's bad. And of course, in the middle, there's the sort of just right point. There's something which is just right. And we have words for this in software design. If you're doing domain-driven design, you might call this a bounded context. You don't need to know anything outside of that. And even in the small, we'd have something like the interface segregation principle, where you're only supposed to have the interface, the interface is only supposed to expose the things you actually need, not the things you don't need. So there's lots and lots of design principles around this idea. Now let's look on the security side of things. Exactly the same kind of thing. There's a spectrum, and on one end, you don't have enough information and you can't get your work done. And on the other end, if you have too much information from a security point of view, that's dangerous. That's a potential for abuse. If I need your email address, it doesn't mean I should also have your bank details, right? I only need your email address. Don't give me anything more than that. So that's dangerous. And again, there's a point in the middle, which is sort of just right. And the security people have a word for this, which is the principle of least authority, or polar. And there's other words for this as well. But the idea is you from a security point of view, you just have enough power to do what you need to do. Like even when you're, even if you're an admin on your own computer, you tend not to have permission, to delete the file system. You have to kind of elevate your rights to be a super user. Even as a regular user, you don't want to have rights, right? You want to make sure that's something you don't do accidentally. So that's the security idea. And it turns out there's a lot in common. Security and software design have a lot in common. From a software point of view, we want to have an intention revealing interface, right? You should only expose what you want me to do. We want to minimize copying. We don't want things to depend on each other that they don't need to. We want to have explicit dependencies. We don't have a kind of implicit dependencies. So basically all these things are about minimizing your surface area, like only expose where you absolutely need the minimum amount of data that you need to expose. And that's good software design. Now, from a security point of view, we have things like the principle of least authority, which is, again, the same idea. You minimize your surface area. You only expose what you absolutely need to expose. So it's exactly the same idea. So good security gives you good design, and good design gives you good security. So that's the thing I really want to, the first thing I want you to take away from this talk. So in the security aware design, there's various words that you use. And in the software design, we have, like I said, we have the solid principles and various things. Now, security people have very specific words that mean specific things. And the word I'm going to use a lot is authority. The authority is, what are you allowed to do? What authority do you have? What can you do at any point? And as from a security point of view, we want to be very careful about what authority we give people. We do not want to give you the authority to delete everything on all the files on your computer, right? You have the authority to read this file, but you don't have the authority to read some other file. And security people always assume that everyone else is malicious, that everyone else is trying to destroy your code, right? That's they have that mindset. So everything is, how can I stop people doing something bad? Now, you might think that malicious people, that might be kind of paranoid. You think about people being malicious, but you know, stupid people and evil people, pretty much the same thing. I mean, a stupid person can delete all your files just as badly as an evil person can, right? So you want to stop people who are both evil and stupid, and more likely it's going to be stupid people, and including the most stupid people is going to be you, right? I mean, I have to watch out for me doing something stupid when I accidentally delete all the files on my computer because it's 3 o'clock in the morning and I'm tired and I click the wrong button or I type the wrong thing. You know, I have to watch out for me being stupid. So it's a very good principle. You can think that people are trying to be evil, but in fact, people are just stupid. So that's the problem. So from a security point of view, we're going to use POLAR, principle as least authority, as a software design guideline. So we're going to, if we use this, we're going to get this intention revealing interface. You're only allowed to do certain things, and it minimizes the surface area of what you're allowed to do. So that brings us to these things called capabilities. What is a capability? Right, so let's say we have some sort of API and we have a client that's using this API, and I call this API, and the API says, actually, you're not allowed to do that. And then I call some of the API again, and the API says, sorry, I can't do that. And this is quite a common problem where you try and call the API and it won't let you do it. And it's kind of annoying because rather than saying what I can't do, why not tell me what I can do, right? Rather than just having an API and saying, hey, you can do anything. Oh, no, you can't do that. Why don't you actually tell me what I can do? And then that makes my life a lot easier. And that is the ultimate sort of intention revealing interface. So if you think about this, this is called a capability-based API. And an analogy for this is a key, right? A key is a capability. It's something I'm allowed to do. If I give you the key to the office, you are allowed to go into that office. You're allowed to open that door. So that's the allowing you to do something rather than the other thing would be to have a door that's wide open. And as soon as you go in that door, somebody pushes you out and says, sorry, you're not allowed to come in, right? That's kind of annoying because the door was open and I walked in. I didn't realize I wasn't supposed to walk in, you know, and then somebody kicks you out. That's kind of annoying, but having a locked door and a key that I know exactly what I can do and what I can't do. So that's what we're going to, think of a capability as a key. So from an API point of view, this is what it's going to look like. Let's say I log into some sort of service, and the service is going to give me back a bunch of keys, a bunch of capabilities. And each key will allow me to do one thing. And initially, when I first log in, maybe there's, 6 things, 10 different things I can do. Okay, so I then use one of those capabilities to do something. And now I'm in a different system or a different state, and I get back a couple of other things I can do. So I click onto this page, and now there's 2 things I can do. I can update my username, or I can change my password, whatever. Okay, so this whole thing of I do something that gives me back some more capabilities. This is back and forth. And each time I do something, what I'm allowed to do changes based on where I am in the system. So I'm going to give you a real concrete example of this, which is designing a tic-tac-toe system like this. I don't know what it's called in other countries, but in the UK, in America, it's tic-tac-toe. In the UK, it's called noughts and crosses. I'm sure you know exactly how to do this game. So let's see how this works here. Now my computer just seems to have frozen up. Hold on a second. Okay, sorry about that. My computer just froze for a second. I think it's Zoom or something. Right, where were we? Yes, okay, so we have this tic-tac-toe as a service. So I make a request and I get a response back. So noughts and crosses in the UK. Now, the obvious way of doing this, if you were going to design an API, would be to have a request object and a response object. So the request is going to look something like this. Here's the player. I'm making a play, and which row do I want to play, and which column do I want to play? So I send this to the server, and the server sends me something back, and the server is going to send me a response, and it's going to have 3 different choices. It's either going to say, okay, keep playing, or the game is won, and here's the player who won it, or the game is tied. And this is this code, by the way, is F# code. That's not really important what the language is. So this is F#. And in F# we have these things called a choice type, which you can think of as a kind of enum, or you can think of it as like 3 different subclasses. It doesn't really matter, but there's 3 different choices of the response. So let me actually do a demo of this game here. Where are we? Okay, the RBAC one. This is the one I want. Right, so this is F# interactive code. Very nice. So hopefully you can see my screen. I'm just going to open the chat, actually, just to make sure that if there's any comments, I can see them. Okay, so I'm going to move, I'm player X, and I want to move to the top left column. Okay, I'll call the API, and the API says, okay, that was good, keep playing, and this is the state of the game. Okay, now I'm player O, and I want to play in the bottom left square. Okay, and it says keep playing, and there it is, that's the state of the game. Okay, I'm player X, and I want to play in the top right, and there it is, and I keep playing. And now I'm player O, I want to play in the middle center, and it says keep playing. And now I am going to play in the top center as well as player X. And ta-da, I won. Game player X won. So that seems like a decent enough API. But here's the problem, is the player can keep playing when the game is over. For example, player O might say, well, I don't care that you've won. I am going to play in the bottom right down here. Oh, and look, he's played. Now I'm going to play in the bottom center as well. Oh, look, I won. Player O has won. Oh, okay. I thought player X had won. And then the player can play twice in a row. It's like, oh, I can play this again, and I can keep playing, and I can keep playing over and over again. And I can already play a move that somebody else has played. It's like, actually, I don't want player X to play up there. I want to play player O up there. Oh, look, player O is now up there. And I want to play O here too. So now, you know, I've got like 4 O's on the board and 1 X. So something went really wrong. I obviously have some sort of bug in my API because the API shouldn't allow it. But from a user point of view, how am I supposed to know? I don't know the rules, right? It relies on me as the user, as the client, knowing what the rules are and not doing bad things. So this is not a very intention revealing interface. So if we go back and look at this, we can say that a player can play an already played move. That's bad. A player can play twice in a row. That's bad. A player can forget to check the response and keep playing, and that's bad as well. So all these bad things can happen. So this is from an API design, this is bad. I mean, we have to trust that the players will use it properly. We might have a security, a bug where people, we forget to handle something and people make mistakes, or they deliberately make a mistake, or they accidentally make a mistake. So this idea of an intention revealing interface means that you should not have to understand how the back end works. As a user of this API, I shouldn't need to know the rules of the game, right? I should just be able to have an interface and I use it. No matter what I do, it always works. And so I don't want to know the rules of the game. So instead, don't let me do a bad thing and tell me off. Instead, you want to make illegal operations unavailable. So I cannot actually make bad moves because I actually cannot even call the API. How can I make it so I can't even call the API? So this goes to this capability idea where I make a game and you give me 9 capabilities, 9 different moves. Okay, so I pick one of these capabilities and I make a move, and now I get back 8 available moves. Okay, I pick one of those moves and I get back 7 available moves, and so on and so forth. And eventually I make a winning move and I get back no available moves. I literally cannot make any more moves because there are no more moves to make. So this is how it's going to work from a code point of view. Instead of just giving you back, it's your turn to move, I'm actually going to give you back a list of capabilities. If it's keep playing, it's like, here's all the things you can do next. Okay, otherwise the game is over. So what is this move capability? A move capability, well, it's like I say, it's just it's something you can do. It's one of the moves you can make. It's the key. It's one of the doors you can open with the key. So the first time there'd be 9 different things. Okay, so a capability is actually just a function. It's like you call it and it makes a move. That's all it is. So if you're in C# or Java or something, that would look like they'd be called a func with that. So that's a capability is just a function. And finally, we start the game. We just say, here's the initial moves you can make. So this is the entire API for tic-tac-toe in the capability-based design. And notice there is no request, right? There's no request type. There's no authorization. There's no way of saying this X's turn to play or O's turn to play, right? In the original API, I had to say which player is it's turning. It's like in this one, there is no, when it's X's turn, all the capabilities that come back are O's turn to play. So I literally cannot play twice as X. So let me give you a demo of that. So this is the capability API. Right, so let me open this up. Right, so I'm going to start a new game. Now, the first thing is you see I get a whole bunch of stuff back. I actually get 9 different capabilities back, and it says this is the actual function to call. And these are just notes, right? I can't actually say to play in a particular, all I can do is pick one of these things. So this is really just a comment that helps me decide which one of these things to do. So if I'm going to play the top left one, I'm going to take this capability and call this function. Okay, and that gives me this result, and it says keep playing. And now I've got 8 different functions I can call. Now notice that these are all player O. I cannot play as player X, and I cannot play in that top left again. That is not one of the capabilities. I've only got 8 possible ones here. All right, let me play this one. And now I get 7 capabilities back, and they are all for player X. So again, I cannot play as player O. And then I'll play again. And now these are all for player O. And now these are all for player X. And now player X is going to play and win. And look what happens. There are no more capabilities coming back. The game is over. The game has been won. The list of capabilities is empty. So I cannot keep playing. So if I try and play a move that's been played, that is not, I mean, there's no thing I can do. There's no capability for me to play. So it's just literally just an error because there's no option I can play. And I can't play the same move twice because again, that capability is not there. If I try and play this move, that top left move is not a capability. If I try and play it, it just says I can't find that capability. So that's how that works. So all the kinds of errors that we had in the first thing, they can't happen, right? You can't play it same move. You can't play twice in a row. You can't forget to check the response and keep playing when the game's over, because when the game's over, there are no more moves you can make. So that's all fixed. So is this good security? Is this to stop malicious players, or is it good design? Because as a client, I do not need to understand the rules of the game. All I have to do is pick one of the moves and play it. So finally, I'll do this and then I'll take a little break for questions. If you're familiar with hypermedia as the engine of application state, hate OS, this is the REST principle of REST, right? Where the idea of REST is that you have hypermedia, you return a bunch of links and you pick one of the links to run, and the client does not need to understand the back end. It just needs to pick one of these links and run it, right? So that's RESTful domain modeling done properly. So often you'll see a kind of RESTful interface that looks like this: post to the customers, get a customer. This is really bad because if you can guess the API, you're basically doing it wrong. And again, it's as bad from a design point of view because people kind of hard code these things in their clients, and then you end up, if you need to change this API, all your clients will break because they coupled themselves to this. And it's also bad from a security point of view because I could start guessing that maybe it's a customer 33, maybe it's a customer 44, or maybe I can see their data, and that would be bad. So this is the bad way of doing it. The correct way of doing it is this, right, where I've literally no idea what these numbers mean, and they are just returned to me, and I have to like pick one of them and do something. So you only know what you can do by actually looking at the response on the page. And that's a capability-based design. Each of these URLs is basically a capability. So this is what a response would look like. Here's all the different capabilities I have. And again, the capabilities are actually the URLs. And the other stuff, this rel is just documentation for what the capability is. I can't actually force it to play in a particular, I can't play, you know, the same move twice. This is just documentation, a comment. The actual capability is the link. So that's just the, you know, this helps me as the user figure out what these links actually do, but I can't force it to play a particular location. So let me do a quick demo of that. So here we go. Here's our capability API. And there we go. We have 9 capabilities, and each one of these is a URL. So if I want to play the top left, I have to pick this URL and run it. Okay, and then I've got 8 capabilities left, and I want to pick this one and run it. Now I've got 6 capabilities left, or whatever, 7, and I pick one and run it. Oops. and now I've got 6 left, and you can see the game is going on and on. So it's the same, exactly the same idea. So good security, good design, and good security. So this is a good, probably a good stopping point for any questions. And I can, I'm not on YouTube, so if you can just read them out to me, Niels.
Yeah, I was just having a look. It looks like it's a quiet bunch, so not that much questions really yet.
Okay. All right.
Everything is just crystal clear, probably.
Okay, good. And you can hear me okay? Sounds good?
Yes, everything's good, yeah.
Excellent. Okay. Right. Well, okay. So that's the basic idea of capabilities. And hopefully you can see how they work in practice. And like I say, if you're doing the kind of hypermedia modeling for your websites, that's capabilities based design right there. So what are the design consequences of using capabilities? How does it change the way you write code? So we can use these this idea not just for APIs, but kind of anywhere in your architecture to try and keep things being modular, right? To stop coupling by accident. So let's say you want to read a customer from a database. Very simple example. And let's say you're using a layered architecture like this, where you have something called a controller or an API. Then you have your business logic and you have a database. And I'm just using a layered architecture as an example, but you could use the onion architecture or ports and adapters. It doesn't really matter what architecture you're using. For this purpose, it's the same thing. Right, so which component in this system decides whether you are allowed to read the customer data from the database? I want to read this particular customer. Am I allowed to do that? So often we put the logic in the controller or at the very top layer, and we have some, what's your identity, right? We've authorized you already. You've already logged in. It's like, what is your identity? And are you allowed to read this customer? The problem is if you do it there, in that particular controller, maybe some other controller didn't bother to do that. Or maybe there's a backdoor that it wasn't checked. And so it's pretty, you have to watch out for bypassing and getting access to the database through a backdoor like an admin interface. And that's a security problem. It's also a design problem. What happens if you try and put the access down here in the database? That's also problematic because you don't have enough context. You don't know really, are you allowed to access this customer, because you don't really know who the identity is. You don't know what the use case is. Lots of different things. So that's also tricky. This is a tricky problem. And we'll address this later on in the talk. But normally what people do is they have something like a global authorizer, and the global authorizer supplies the authority to read the database. So in the controller, you say, am I allowed to read the database? And if I am, I will then call the database, right? Now, I'm willing to bet that a lot of you are actually using this model. And you might probably say, actually, no, we're not using a global authorizer. So we don't have anything like this in our code. But if instead of calling a global authorizer, I call it dependency injection, then you probably are doing something like this. And your authority is the interface, the database interface. So let's kind of look at some code. This is C# code. Let's say we have a customer controller, and there's some sort of constructor injection, right? I have some interface to the customer database, and I'm going to pass it in the constructor. And then later on in one of my methods, I'm going to use that database interface to get information out of the database, right? Very, very common code. Right, so what's going on here is this is the authority. The interface that I'm injecting gives me the authority to access the database. That's exactly what that is. And once I have that authority, then I can use the authority later on. So you don't normally think of things in the security terms. We normally think of this in other terms, but from a security point of view, it's interesting to think about this as do I have the authority to access the database? If I have access to one of these interfaces, I do have authority to access the database. And if I don't have access to one of these interfaces, I do not have authority. So I'm injecting the authority into my controller and then using it later on. Now, here's the problem with this approach is how much authority do you really need? Because we have this kind of interface, and there's a, one of the methods on this interface is getting the customer profile, getting the email address or whatever. And maybe there's another method which is updating the profile, and another method which is creating a customer account, and another method which is deleting an account, and another method for changing the email, and another method for updating the password, and so on. Now, there's a lot of different, it's very easy to put lots and lots of methods on an interface. And I think it's problematic, because what's going on here is that for this particular use case, all I need is that particular authority. I just need the ability to get the customer data, right? But you are also giving me the authority to update the password. So if I was a malicious developer, I could change your password as well as getting your, getting your data. And again, it doesn't have to be malicious, doesn't have to be evil. It can just be stupid. Like I could accidentally change your password by mistake because I was being stupid. And that's much more likely, to be honest, but it's the same problem. I have too much power. I shouldn't be able to do that for this particular use case. So what we're going to do is get rid of all the methods I don't need for this use case. Now I have an interface with one method in it. And that's the only thing I need for this particular use case. Now, updating the password, that might be something else I need in a different use case, but not in this one. Now, at this point, I have a whole interface just for one method. And I would say you don't really need to have a whole interface. Instead, just use a function, right? Interface with one method is just a function. And this is one of the reasons I like functional programming, because functions are very easy to do. So here we have a function. You give me an ID and I'll give you back the customer profile, the name and address and all that. So the first step is to inject capabilities, not interfaces, right? Don't inject 20 different things, just inject one thing. So this is what it looks like using a capability-based design. I'm injecting a function. I'm not injecting an interface. I'm just injecting a function, and that function says you can read the customer from the database. So when I use it, I can read the customer, which is exactly the same thing. But what I can't do is I can't accidentally update the password. That is not one of the options. So I can't make a mistake and do something bad. So I think this is a better way of doing it. But now the problem is that I have my use case and I have my global authorizer, and it's just injecting the minimal amount of authority that I need to do this one particular thing, which is maybe read the customer data. Now I have another use case, and that needs different authority. It needs to be able to do different things. So I'm going to inject something for that. And I have another use case, and it needs to update the password or something. So I'm going to inject authority for that. And so I end up with all these use cases, and each use case only has the minimal the minimal authority it needs to do that particular thing. And when you design your code this way, you end up with vertical slices, right? You have, instead of having kind of these horizontal slices, you have each use case is one thing, and all the code for that use case lives in one place and lives together. So vertical slicing, this is becoming quite a popular technique as well now. You can also, don't mention microservices, because microservices are also popular for the wrong reasons. But the idea of having things which do one thing and that's how you organize your code is a really good, I definitely think it's a very good way of doing things. But there's more, because in this code, I was given permission to access any customer, right? It said, get the customer. Well, I could get the wrong customer ID. Again, I could leak out the information for a customer that I wasn't authorized to access. And that wasn't tracked at all. So we want more fine-grained access control. So what I'm going to do is go to the authorizer and try and get a capability to read a particular customer. Do I have the capability to read my own information? Well, yes, I do. Do I have the capability to read your information? No, I don't. So it's not can I get any customer? Can I read a particular customer? And I get this capability back from the authorizer. And then I have to see, is it valid or not? So either I get it or I don't. If I do get it, if it's valid, then I can get the customer back. I can use that capability. If the capability is not available, like if it's somebody else's customer, then I don't have a capability to read. I cannot call it. I do not have a function to call, right? So there's an attempt to try and get a capability, and then I check whether that capability was given to me. And if it was given to me, I can use it. Now, notice that when I do use it, I do not need to pass the customer ID in anymore. That is baked in to the capability. That capability is only good for reading this one particular customer. If I want to read another customer, I need to get a different capability, right? So this is very, very specific to this one particular customer only. Now, one of the nice things about these very specific functions is they are extremely easy to transform. Functions are wonderful because you can transform a function into another function that looks exactly the same. And so I'm going to call these capability transformers. So a capability comes into this transformer and it gets transformed into another capability which is constrained somehow. So let's look at some examples. So you can use business rules, especially to constrain these things. So for example, very easy to audit. I want to know who used this capability. When did they use it? Right? I want to audit, like, use this capability on this date to do this thing. Maybe I wanted this capability to only be usable in office hours. If you're trying to access a customer outside of office hours, that is not allowed. So I might have a constrained one. I might have a capability that's only used once. So I'll let you read this customer once. I'm going to let you use it, but I'm not going to let you do it any more than once. And also revoking access. So I might give you a capability to do something, but if I don't trust you anymore, I'm going to revoke it. Now, in the real world, it's hard to revoke. If I give you a key to open my door and I want to revoke that, a real physical key is hard to revoke. What I have to do is change my locks, which is really painful. But in the software, it's easy. So what we do is we have a self-destruct button that will destroy the capability. So what happens is I pass in a capability and I get back two things. I get back a revocable capability, which I give to you, and I have this self-destruct button, which I can press at any time to destroy that. And we can also we can combine both of these things, a timer. You know, I'll give you this capability, but after 10 minutes, it expires. And this is the kind of thing you see all the time, like a password. When you get a link to reset your password or a link for an authorization, often it says you have to use this link within 10 minutes or within an hour, right? There's a constraint. Doing that kind of logic is really, really easy with this model. So let me give you a demo. And this is the capabilities here. Okay. Right. So here we have a customer and a customer profile, which is just a name. And here is my very sophisticated database. And this is like, if the customer is 1, I'm going to return Alice. And if the customer is 2, it's Bob. And if it's something else, it's something else. So this is my very sophisticated database system. And let me see if I can transform this capability. So the basic capability is just to get the data from the database. So let me get customer number 1. Okay, I got Alice. Let me get customer number 2. Fine, I got Bob. So that's easy. But now I want to know who actually was using this capability. So I'm going to add an auditing, right? So I'm just going to put a timestamp. You don't have to worry about exactly what the code is. It's just a few lines of code, but it's just going to keep a track of the time, and it's going to log every time it's used. So here's my audited capability for Alice. So when Alice is the user, every time Alice has used this capability, it's going to log it. And every time Scott uses this capability, it's going to log it. So if Alice calls it, it says, Alice used this capability at this timestamp. And if Scott uses it, it says, Scott used this capability at this timestamp. So now I've got some auditing going on. I can know which particular person used this capability at which time. That's very good. How about only allowing it to be used once? So I want this capability. I'm going to let Scott do this thing, but I'm only going to let Scott do it once. Now notice that it has exactly the same interface. Every time we transform these capabilities, they always look exactly the same. They always say, you give me an ID and I'll give you back a profile. So it looks the same, but the logic inside is very different. So the first time, then I'm only going to do this once. So I'm do it once, and it worked. There it goes, it worked. Now let me try and do it again. Oh, boom, I got an exception. I was only allowed to do it once. So again, that's very useful for things like password resets or any kinds of things where you want something to do it once, but then, you know, you don't want to have a kind of replay attack, right? Okay, here's the revocable thing. A little bit more complicated. Right, so when I get a revocable, I actually get a pair of things back. I get the revocable capability and I get my self-destruct button, the revoker. Now here's my revocable capability and I can call it. There it is. And I can call it again and again and again and again. And now I don't trust you anymore. So I'm going to revoke this capability. And now if I try and call this capability one more time, bam, system exception capability has been revoked. So that is one of the really nice things about, we start off with a very simple capability and we can add to it, we can add auditing, we can add constraints and various other techniques to that. So capabilities are a really cool way of adding constraints to things you can do. And one particular thing you can do is also delegate authority using capabilities. So if every time you want somebody else to do something for you, that's delegating. And one of the things about regular access control is that it's very annoying to do delegation. I mean, if you think about traditional access control like passwords or swipe cards on a door, you know, first of all, they stop you having access at all, which is good. They often limit you to access some things, like, you know, if you have a password, you can get into some parts of the system, but you can't get into other parts of the system. And also, if you want to revoke something, you know, if I take away your password, I take away your swipe card, you can no longer get into it. So that's fine. But one of the things we often want to do is delegate access to some subset of things. I want you to be able to do something on my behalf. And this is really hard with a role-based access control, password-based or something like that. Very hard to do. Okay, so it's not always about saying no. We always think about access control as like forbidding people to do things or not letting people do things. Sometimes we want to let people do things and we want to make it easy for that to happen. So again, if you think about a key-based system, in a key-based system, you have lots and lots and lots of keys, right? You have, you know, hundreds of keys, and each key opens one door. And what the good thing about that is that I can give you the key to one door, but it won't open another door, right? So this is definitely a capability-based system there. So what's nice about this is it's decentralized. So let's say that Alice has a bunch of keys and she wants me or she wants Bob to go and get some paper from the supply room. So what she can do is she can give Bob her key for the supply room. She trusts Bob that much. Bob can go and get some paper and bring it back to her. Now, if Bob tries to go to the secret room to get the secret files, that key does not work on that door. And so he cannot get the secret files. So this is an example where Alice will trust Bob to do some things, but Alice does not trust Bob to do other things. Now, if you have like a swipe card system in your office, you probably have the system where, you know, you don't have permission to get to the supply room because you've only been working there 6 months. And so somebody might lend you their swipe card, which is really dangerous, or they might tell you their password, which is also really dangerous. I mean, these are really, really dangerous things to do. So decentralizing delegation is a great way to do if you can do it. Let me show you some examples. This is an example. This is Google Docs. And I have a document. I've written a document on Google Docs. I want to share it with people. I don't want to share my Google Docs password. Right, I just want to share this one particular document and I want you to be able to read it. And here we go. I give you a link. Okay, this is a capability. You are allowed to read this document. And this is a revocable capability because I can go to Google and forbid you from reading this document. It's not a time constrained, it's not a once only kind of thing. And I can't do it between office hours or whatever, but it's basically a capability. This URL is a capability that allows you to read this document. And I have another one. You can have one where you can read it, and you can have another one you can edit it. Here's another one. This is Dropbox. Same thing. I have a bunch of files on Dropbox, and I want you to be able to read one of those files. So again, I don't have to give you my Dropbox passwords. I don't have to give you access to all my files. I just have to give you the key to one particular file. And that is done as a link, right? It's an unforgeable token. So it's very, very common. We see it all the time now. So here's another example of something which is based on something actually happened to me. We had a system which needed to send emails. So typically when you place an order, like an e-commerce site, you place an order on the website, and after you've placed the order, you send the customer the email. So, what would happen is, by mistake, the email service had full authority to read all the customers in the database. And we made a mistake where it would send by mistake, it sent the same email to every customer in our database, like 100,000 customers. And it was only meant to send one email. And that was a mistake. And it was a stupid mistake done by one of the programmers on the team. Now, in my model, with the authorization model, this could not happen, because what we'd do is we'd inject the authority to read one customer to this API, just like we did before. And then that API, so this is the bad way, where the email service has the authority to read any customer, which is bad. So it's very, very dangerous. We really want to restrict what you can do. So instead, what we're going to do is give the controller or the service the authority to read one customer, and then it's going to pass that authority to the email service. So the email service can only read the same customer that the website read, right? It's guaranteed to be the same customer because it's the same capability. So they can't possibly read the wrong customer. It can't possibly mix up customers. It can't possibly send it to more than one customer. All that stuff is taken care of because it's using the same capability that the original controller did. So this is a much nicer, from a design point of view, this will stop a lot of bugs from happening by mistake. So this is a much better way, much better model. And of course, these delegated capabilities can be transformed. So let's say I start my system and I have all these capabilities. I can do anything. And I'm going to delegate some capabilities to Scott, and I'm going to delegate some capabilities to Alice. Now, what I can do is transform them. So Scott, the capability I give Scott, he can only use once. And the capability I give to Alice can only be done during office hours. So, and then maybe Scott will give the capability to somebody else, or maybe Alice will give the capability to somebody else. So you can keep, you can pass these capabilities around, and you might say, well, isn't that dangerous? Like, what happens if somebody gives the capability to somebody who shouldn't have it? It's just like having a key, right? I have the capability to open this door. What happens if I give that key to somebody else? Then they can get into this door, and maybe they shouldn't be allowed to get into the door. And the answer to that is, this is also true with role-based systems too. If I have a swipe card that let me get into a door, I can lend that swipe card to somebody and they can get into the door, right? So it's basically, who do you trust? If you trust me to delegate, then trust me. And if you don't trust me, then don't give me permission to do something. If you don't trust me to look after my permissions, to look after my authority, then it doesn't really matter whether you give me a swipe card or whether you give me a key, because either way, if you don't trust me, I can give it to somebody else. So it's nothing to do with whether it's using a single capability like a key or a role-based capability like a password. a swipe card. Like, you know, if a password-based system, I could give my password to somebody else and then they could do everything I can do. So that's not what stops something being secure. Right, and finally, well, it's a good stopping point there. Any more questions? And then I just got a few more minutes after that.
Yeah, I don't see any questions yet. So
okay,
keep on going.
Right, so the last bit, I just want to talk about decentralized authorization. And again, this is a system that's used in security systems, but it's also good for software. So this is OAuth. And in OAuth model, you know, the idea is you have different systems and they are decentralized. They don't really know about each other. But I need to, you know, one system needs to access another system in a secure way. And so there's what basically is there's this authorization server down here in the bottom, and it gives out access tokens. And the access tokens are allowed to use the actual thing. And here's another one. This is Kerberos. And again, there's this key distribution center, which is the authorization server. And you get these access tokens or service tickets, and they allow you to do things. So what's the equivalent? I mean, this is obviously a very complicated system. What's the equivalent in our software? So in our software, what we want to do is we want to get an access token from our global authorizer. And we will pass this, and an access token is a non-forgeable signed token that represents a permission to do something. It's a capability. And it's non-forgeable, meaning that if you've got it, it's guaranteed to be allowed. If you have it, it's allowed, and if you don't have it, it's not allowed. You can't fake it. And then I take this access token and I pass it to the service, like the database service. And then the database service can check that the token is valid. And if the token is valid, then you're allowed to talk to the database. So that is the kind of access token model of doing authorization. And you might think that's awfully complicated. The advantage is it is decentralized. I mean, the controller and the database, you know, can collaborate without knowing too much about what's going on. It's the global authorization, the global authorizer that hands out these tokens. However, there is a very simple way of doing this, which is to use, instead of using tokens to do decoupling, you can use types. So this is too complicated, you might think, but let's use types as access tokens. So in this one, instead of getting a token, we get a type from an authorizer. And then the controller will pass an instance of that type to the service, just like we do anyway in all our code. And then the database, to check whether the type is valid, it doesn't need to do, that's called type checking, and your compiler will do it for you. You don't need to have any special token validation thing. It's called just type checking. You don't need anything special at all. If you have the right type, then it will compile. And if you don't have the right type, it won't compile. That's called type checking. It's also called validating your token. So you can call it both things. So it sounds complicated, but it's actually pretty easy to actually work with in practice. So let me give you a quick demo of that. So this is the type-based access control. Okay, so we have our custom ID, we have our profile here, and we have these two tokens. So this token is going to allow me to get the customer profile, and this token is going to allow me to update the password. So again, you can see it's just a type. Now inside it is the actual customer I'm allowed to talk to, right? So you could have any kind of data in here. In this particular case, it's just the customer that I'm allowed to talk to. Right, now here is my database. So my database interface has two methods on it. You give me a profile token and I'll give you back a customer. Now notice that I don't have to give you the customer ID. You give me one of these tokens. Now, the ID is already embedded inside the token. Now, this profile token guarantees that you are only allowed to get custom IDs that the authorizer lets you get, right? You can't get any old custom ID. You have to pass in one of these profile tokens. Similarly, update passwords, right? You pass in one of these tokens and a new password, and that will work. Now, Again, which particular customer is it? That's embedded inside the token. You cannot update the password for somebody who you do not have a token for. And where you're going to get one of these tokens from, you're going to get it from the global authorizer. All right. So here we go. This is the getting the profile. This is like my same database logic. I've changed them to be 65 and 66 for reasons that I'll talk about in a minute. And then again, update the password again. So the database doesn't do any kind of, doesn't have to know about anything who you're. All the database needs to know is if you have a token, you are allowed to do this. If you don't have a token, you are not allowed to do it. So that is my database code there. All right. Now the authorization is kind of this. This is the thing which gives out these tokens. So you give me your identity and you give me a custom ID, and I will give you a token, maybe optional. So if you are allowed to access that customer, I will give you a token. And if you're not allowed to access that customer, I won't give you a token. Right? It depends on who you are, it depends on your identity, and it depends on the custom ID that you're passing in. So in this case, to get the customer data, if you're the admin, or if your identity is the same as the customer, like you can fetch your own profile. So if you're the admin or it's you can get the customer. Otherwise you can't. Now for updating the password, it has to be you. So even the admin can't update your password. The admin is not allowed to update you. The admin is allowed to see your customer details, but it's not allowed to see it's not allowed to update your password. All right, so that's the authorization system. And this is the email system. Now the email system is given a capability, and all this capability is get an email address. That's all it can do. It gets one single email address. So from the database, that's the only thing it knows how to do. All right, now we've come to our top layer controller, and this controller is being injected with the an interface for the database and an interface for authorizer. So when I want to get a customer profile, I pass in my identity and I pass in the customer ID. And the very first thing I do is try to get a token. Now the token might succeed or might fail. If it fails, I don't have permission. Now, if it does succeed, I do have a token, and then I can use that token when I talk to the database. And then I can then create a new capability and pass that capability off to the email. And similarly, when I try and update the password, again, I try and get a token that allows me to update the password. If I can't get a token, I don't have permission. And if I can get a token, I can update the password. So the logic of what I'm allowed to do, who's allowed to do what, it's not in the controller. Often this authorization logic is who is allowed to access what things at what time is often quite tricky. And it's sometimes what we don't want to do is have it in the controller because that's too messy, and we don't want to have it in the database. That's too messy. So all that logic is now separate it's in the authorization system, and all the controller has to do is just see if it can get authorization to do it. So that's the complete controller. So let me build a controller, and we have our Alice's. A and B is Alice and Bob. So Alice is logged in. Can Alice access the Alice customer database record? And the answer is yes. Alice did fetch it, the profile, and it did send the email. So that's all good. Now, if Bob is logged in, can Bob fetch Alice? And the answer is no. It says you don't have permission to read that profile. Now, if you're logged in as the admin, are you allowed to fetch Alice's data? And the answer is yes, you are. Now, what about if you're Bob? Can you fetch, if you're logged in as Bob, can you get Bob's information? Yes, you can. If you're logged in as Alice, can you get Bob's information? And the answer is no, you can't, and so on and so forth. Now, what about the passwords? If you're logged in as Alice, can you update the password for Alice? And the answer is yes, you can. Password of customer updated. Now, if you're logged in as Bob, can you update the password for Alice? And the answer is no, you don't have permission to change the password. And finally, if you're logged in as the admin, can you change Alice's password? And the answer is no, you don't have permission to change the password. So all this stuff is, all that kind of logic is not in the control. The controller logic is basically very simple. It's basically try and get a token and then try and use the token. And I can't accidentally get the wrong kind of, I mean, if I try and get let's say, for example, that I'm going to be sneaky, and instead of getting a password token, I'm going to try and get a profile. Now, as the admin, I can get a profile token, and then I'm going to try and I'm trying to update the passwords with the admin token. And oops, I got a compiler error. It says this expression needs to have a password token and you give me a profile token. So I literally cannot do something bad. I can't accidentally do the wrong thing. Now, more than being malicious, like I say, it's not, chances are I'm not deliberately trying to do something bad. More likely I just copy and pasted the code by mistake, right? I've made a silly mistake, and I've reused the same piece of code, and I didn't realize I was making a mistake. Now, if I'd reused the same code and I wasn't doing this token thing, I could have quite easily had the admin be able to update users' passwords, and that would be a security breach. And you know, this guarantees that can't happen without being too heavy-handed about it. So the only way I can get the password, the only way I can get that compiler error to go away is I have to get the right kind of token back. Right, so that's using types for access token, and that is it. So let me just review some of the stuff I talked about in this talk. So there's some very common questions people have. First of all, is this overkill? Is this too much work, you know, to have all these capabilities and have these tokens and stuff? And the answer is always, it depends. First of all, I think it's a really interesting way of thinking about programming. So I think it's worth playing with. I think it's worth understanding. I think it's another tool in your toolbox. I think if you do have systems where you are dealing with lots of customer data or lots of anything which is secure, I definitely think this is a good way of doing things because it stops you making stupid mistakes. I mean, most of these terrible data breaches are due to people, normally just accidents, like there's a backdoor into the system that they forgot to check, or they for some particular path through the system was not checked properly, and they ended up with a security problem. So yeah, I do think security is going to be bigger and bigger problem moving forward. And so I do think we need, as developers, we need to think about this a lot more than we normally do. How does this relate to the design process? So as I was saying, this is not just about security, it's about software design. And what I like about this is intention revealing interfaces. The interfaces that if you follow this approach, you get these interfaces which limit you to what you're allowed to do. So that's a good from a security point of view, but it's also good because it's like, this is what you're allowed to do. You're only allowed to do these things and you can't possibly do anything else. So, you know, that's good. And if you're doing kind of things like event storming or any kind of design process like this, the kinds of things you do in a design thing, or even when you're just doing stories, they map really well to capabilities. Somebody is allowed to do this thing. As a user, every time you have a story, as a user, I want to be able to change my password. There's normally some sort of capability related to that story. So, you know, it maps very well onto those things. Should all external I/O be passed around as capabilities? Like, shouldn't I just be able to read a database? And I would say no. You should not. You should always go through capabilities. You should always not be able to just read a database by, you know, accessing any record in the database. That is what we call ambient authority. You can do anything. You can access any file in the file system. You can access any record in the database. That is almost always a really bad thing, because either accidentally or deliberately, and most likely accidentally, someday somebody is going to delete everything in the database by mistake, or even just reading every record in the database, sending an email to everybody in the database by mistake. So it's just very dangerous. I would recommend you do not do that. And you should be doing this anyway, because if you're doing any kind of mocking of I/O, That's a capability, right? You have an interface for your IO. How do I pass these capabilities around? Well, dependency injection, right? So if you know how to do dependency injection, you know how to do capability injection. Same thing. What happens if I need lots and lots and lots of capabilities? Let's say I need to update the password, and I need to send an email, and I need to do this, and I need to do that. Won't there be hundreds and hundreds of parameters, right? Each of these capabilities I need to pass it. And the answer is hopefully not, because hopefully your use cases are pretty small. And if you have 20 parameters for all these different things this thing can do, chances are you need to refactor your code, right? So hopefully, normally there's only one or two things you need to do in any particular use case. This is actually a really good way to stop interfaces getting too big. Like if you pass in an interface, it's very easy to add methods to an interface. You can. I've seen interfaces with 40 methods on them, 50 methods, because it's like, well, we'll just add another method onto it. It's really easy. If you're not allowed to use interfaces and you have to pass in 50 functions, 50 capabilities, that's really painful. And you start thinking, do I really need to pass in 50 functions to this thing? Maybe I should refactor it now. And so it's a really good way to force you not to have functions with too many things in it. And it encourages this vertical slicing of your design, which is a much better design anyway. Now, I've mentioned security, but all this stuff I'm talking about, you can bypass it with reflection, right? In most languages, there's a way to bypass this stuff. And yes, there is. So it's not really a way of locking down something 100% from a security point of view. It's really more about designing things, thinking about how you design things better. So there we go. Good security gives you a good design, and it gives you a nice modular architecture. Using the principle of least authority as a design principle is a really good way of doing things. In addition to the solid design principles and all these other things, Polar is a really good one to use. Basically, do not trust other people to do the right thing. Do not force people to read the documentation. Only limit them to do things they're allowed to do, right? So this is these intention revealing interfaces. Don't force the client to know about the rules of the game, the rules of tic-tac-toe. Don't force them to know what the rules are. Just say, here's the moves you can make. And that's just give them the moves they can make, and don't rely on them going to get them all right. So that's it, I think. Hopefully that was interesting. And I will be happy to answer any questions now.
Thank you so much. As always, very informative and easy to understand examples. Really like that.
Good.
I may be able to relate to that email example you had. I can really see a need for security by design. That's
yeah. Sure. Most of these things are through mistakes. Like I say, people being stupid, not being deliberately, just accidentally doing something. And it happened to me, and it was like, uh-oh, that's bad.
Yeah. So yeah, any question, people? We don't have questions yet. Maybe while we're waiting, I have one question at least, because we went into you talked about REST and
yes,
the HTOS. So in that, if we're using REST, of course, this makes perfect sense because you ask the API for the things you want to do. But of course, now also GraphQL is being more popular. Have you any experience doing this in that, using GraphQL or similar?
Yeah, I don't like GraphQL for the same reasons.
Yeah.
Because it's not an intention revealing interface. You can pass all sorts of stuff in, and it's very hard on the server side to think about every possible thing that somebody could pass in and make sure that none of those things can go bad.
Yeah.
I mean, even as something as accidentally reading every record in the database, that would be quite a simple thing to do by mistake if you're not careful. Like you say, you might have a thing where you can have a filter, And if you set the filter to blank, you actually get every record, and that's like everybody, and that might be millions of records coming back over the wire, which will, even at the worst, it'll be a DOS attack on your system. I don't actually like systems which are too flexible. So I mean, I think it's fine if you in the right situation, it may be okay. But I don't like designs that are too flexible, because they end up coming back, and all these people who have GraphQL come back in 5 years and tell me how you're coming on with it.
Yeah,
because we've been there with, I put it this way, I'm old enough to remember when we did the same thing with XML.
Yeah.
People would pass in XML that had these XML query languages, and you'd pass them to the server, and it could do all sorts of stuff. And those are all dead. And there's a reason why they're all dead. So
yeah, well, I can see the reason why some are moving towards GraphQL, because I've done some projects with REST and taking it all the way with HTOS, and it can be kind of chatty
yes
protocol. So
well, I agree about not having chatty interfaces.
Yeah.
And I can understand about why, but I mean, I guess there's a thing about being too flexible versus it depends on how flexible your GraphQL API is.
Yeah.
So I mean, if it's a very constrained, it's like, here's the things you can do, and every possible things is all valid. That's fine. I don't have a problem with that. But I mean, I understand what's going on. It's just it is. I mean, there's no reason, for example, that you can't combine RESTful stuff with parameters. Like, you can call this URL and you can pass in these parameters as well, in addition to the URL, as query parameters to do some extra stuff, which is how people used to do it back 20 years ago. That's how we did. That's how we did RESTful APIs. So I don't have a problem with that either. But I'm just saying it's very people sometimes think it's sometimes making things too easy it makes it easy for now. In the long term, it might not. So we'll see. Yeah.
Just having a look at the question. Not much happening. So I guess this is a Norwegian crowd for you.
Okay.
Oh, we have one question here.
Okay.
Let me read it. Is Joaquin Laquel. Very interesting talk. In terms of onion architecture, which part is simpler to start refactoring towards implementing such a technique?
Well, in an onion architecture, the idea is, and ports and adapters and clean architecture, the idea, all there's the core domain is in the middle, and all the IO is around the outside. And that's an excellent architecture for lots of reasons, mainly because the core architecture is got no IO. It's completely pure. So it's very easy to test. It's very easy to write in a functional style and so on. So the stuff I'm talking about, the authority really only applies to the edges. So in terms of if you refactor to an onion architecture, the main benefit, I mean, even without doing this, the benefits of going to onion is much more easy to test, much more easy to separate the non-deterministic parts like the database and the network from the deterministic parts, which is the business logic. So that's a good idea anyway. If you have the non-deterministic parts at the edges, then it's the question of, how do you grant access authorization? And so this would be a good model for that. But once you've got that, this is pretty easy to fit on top of that, because at that point you've done most of the hard work of refactoring all the stuff at the edges anyway. I hope that answers the question.
I think so.
Yeah,
I think so.
Right. Anyone else having a question? I have a more general question.
Sure.
While we're waiting. More about some question that I'm getting from time to time when it comes to functional programming, and that's regarding dependency injection and how the thoughts about dependency injection in functional programming in general.
Yes.
Maybe something you can just give your thoughts on.
Yes. So if you go to my website, actually there's a whole series. Let me just get my website going here. So if you go to my website, F# Fun and Profits, I have a whole series here called oh yeah, here we go. Which one is this? Oh yeah, here we are. Dependency. This one called if you go to the archives, six approaches to dependency injection.
Yeah. Okay. Sure.
So I have a whole series about keeping all the I/O at the edges. So that would be the onion architecture. And then I talk about doing parameterization, which is partial application. And then I talk about dependency injection, and the functional equivalent of dependency injection would be the reader monad, which is kind of, it might be overkill. And then you can also talk about the interpreter pattern, the OO style interpreter pattern, and an FP that would be called free monads. And I would basically start, these are all different ways of doing it. I would basically start from the simplest one, which is keeping all the IO at the edges anyway. This is just so good. You can do it. And that's, like I said, the onion architecture or the clean architecture or the ports and adapters. And then after that, you can just use regular if you do need to have any other stuff, just use regular dependency injection, or you can just pass dependencies in as individual parameters. In functional programming, it's very easy to do individual parameters because you can use partial application to kind of hide them from other people. But I'm not it depends on what system, there's no single way that I would use for everything. But I would say the biggest benefit would be this first one of keeping this at the edges, and then the rest of the stuff becomes so much easier anyway. So it doesn't, at that point, it doesn't really matter what you use, I don't think.
Yeah.
This one, the interpreter pattern is interesting. I think it's interesting to look at. I would probably not use it in practice unless I really, really needed it. But these are all interesting techniques I think they're good things to know about and put them in your toolbox. Yeah. So anyway, this is just if you just Google that, you should find my my website there.
Yeah, of course. Not the problem, but one thing with the website is you go through all these different concepts, which is really interesting, and you want to try it, but it might also be the hammer or watching using too much or overkill type of
yeah, it is. These are definitely overkill. These last ones are overkill. In fact, and I think on my last post, when I kind of summarize at the very end, I talk about, I actually do have my favorites. And I would say so these are the techniques, and I would say this one's always a good idea. This one is not a technique I would recommend. And I wouldn't really recommend the reader mode either unless you really, really need it.
Yeah.
So, they're useful. In certain situations, they're useful. It's good to know about them. But yeah, basically, I would do it in this order. I do this one first, do this one second, and then do that one third.
Yeah.
And then don't do these at all.
Yeah, and I guess that goes for a lot of things too.
Yeah, it's interesting. I mean, a lot of the stuff in functional programming, it's interesting to learn about, and it's, like I said, it's useful to know about existing. But in fact, on a day-to-day basis, you shouldn't really need it unless they have a very specific use for it. Yeah,
I think a lot of people are a little bit afraid of going all functional because they think they need to know about all these monads and functors and all these things, but really doing just simple functional programming, you don't really need to.
Yeah, I mean, all these ones there's no monads. I mean, there's no monads in any of this stuff. This is just basically good design stuff anyway, whether it's functional programming or OO. Try and minimize dependencies, be explicit, pass in parameters and be explicit if you can. Don't have global mutable states. all that stuff. This is just general good design anyway. So yeah, I actually on my website I don't use monads hardly at all.
Yeah, I realized that.
Yeah.
So I think that's a good thing for at least for people coming from typically object-oriented languages. And
yeah, exactly.
Want to scare them.
Yeah.
Okay, I haven't seen any more questions, so I guess and everything was clear and yeah. And so like I said, the examples are very self-explanatory and easy to understand. And
yes, and if you need, like I say, for people who want to look at this, if they want to see the where it's actually under /cap, I'll just put it here. Cap. There we go. So again, I have some blog posts on this topic, and I have a talk on this topic again, which is similar to the one I just did. And I have the slides here if you want to look at the slides.
Perfect. Very good. Then I guess we're done here, and I thank you so much for attending this, and it's nice having you on BitShift.
Yeah,
hopefully not for the last time.
I know. I'm sorry I can't be. It'd be nice to be there in person, but
yeah,
there you go.
Hopefully next time.
Bergen, I love Bergen. It's a nice place. So one day I'll be there.
Yeah, let's hope so. Okay,
yes.
Great.
Thank you for your time.
Okay, well, thank you very much. Thank you, everyone who's watching, and I hope to see you in person. But yeah, thanks for coming and listening.
Okay.